Hello students, welcome you all for mathematics class. In last class we discussed about the inverse of cos and tan functions. In this class we will discuss about the other trigonometric functions. So here y is equal to cosec x and domain of the cosec function is all real number except n pi, and the range of the cosec function is all real number except open interval -1 to 1 1. This is the graphical representation of the cosec function, and domain value is r minus n pi. It means cosec x means it is a reciprocal of the sine function 1 by sin x. If sin x equal to 0, if sin x equal to 0, 1 by 0 is a infinity. The function is not defined at sin x equal to 0. So domain of the cosec function is all real number except a real number at which sin x is 0, that is n pi value, because you already know sin 0 is 0, sin pi value is 0, sin 2 pi value is 0. So in the same way sin n pi value is 0. Domain of the cosec function is all real number except a real number at which sin x is 0, that is n pi, r minus n pi. So using the cosec angles, so here cosec 0 is infinity. So in 0, pi, minus pi, 2 pi and minus 2 pi values, the cosec function is not defined. So here cosec 0 value is not defined, and cosec pi by 2 value is 1, and cosec minus pi by 2 value is minus 1, and cosec pi value is not defined, and cosec minus pi value is also not defined. This is the graphical representation of the cosec function, and cosec function is not bijective function over their natural domain and ranges. So like sine function, cos and tan function, so here cosec function is also not bijective function over their natural domain and ranges. We make it invertible by restricting the domain value. So here we restrict the domain value from minus pi by 2 to pi by 2 except 0, because in 0 value cosec function is not defined. So that's why we restrict the domain value to the interval minus pi by 2 to pi by 2 except 0. Then it becomes 1 1 and onto. Or apply the horizontal line test. If the horizontal line passes through more than one point on the graph of the function, it is not invertible. If we restrict the domain value from minus pi by 2 to pi by 2 except 0, so observe this graph. So this is the restricted cosec function graph. So here we restrict the domain value to the interval minus pi by 2 to pi by 2 except 0. So here apply the horizontal line test. The horizontal line intersected at only one point on the graph of the function. So it is an invertible function. So cosec function are restricted to the interval, closed interval minus pi by 2 to pi by 2 except 0. Or not only closed interval minus pi by 2 except 0, cosec function restricted to any of the interval, closed interval pi by 2 to 3 pi by 2 except pi value, or closed interval minus 3 pi by 2 to minus pi by 2 except minus pi. So here cosec function restricted to minus 3 pi by 2 to minus pi by 2 except minus pi value. In the same way, cosec function is also restricted to the interval pi by 2 to 3 pi by 2 except pi value. Cosec function restricted to any of these intervals. And inverse of the cosec function. Inverse of the function means changing the domain and range of the original function. So here y is equal to cosec inverse x. Domain of the cosec inverse function is a all real number except minus 1 to 1, open interval minus 1 to 1 value. And the range of the cosec inverse function is a all real number except n pi values. This is the graphical representation of the cosec inverse x. Observe this graph. This is the restricted cosec inverse function. See here, we restrict the domain value in cosec function is a minus pi by 2 to pi by 2 except 0 in inverse function. In inverse function, so here minus pi by 2 to pi by 2 except 0 value is a range value. So here domain value is a all real number except minus 1 to 1. Range value is a closed interval minus pi by 2 to pi by 2 except 0. So here range value is a any of these interval, but the branch with the range closed interval minus pi by 2 to pi by 2 except 0 is a principal value branch. So that's why range of the cosec inverse function is a closed interval minus pi by 2 to pi by 2 except 0. So this is the graphical representation of the cosec inverse function. Observe this. Y is equal to cosec function and y is equal to cosec inverse function. So this is the restricted cosec function. Here domain of the cosec function is a closed interval minus pi by 2 to pi by 2 except 0, and the range of the cosec function is all real number except open interval minus 1 to 1. And in cosec inverse function, domain of the cosec inverse function is a all real number except open interval minus 1 to 1 value, and the range of the cosec inverse function is a closed interval minus pi by 2 to pi by 2 except 0. So then we write the function. Cosec function is mapping from domain to range. So here domain value is a closed interval minus pi by 2 to pi by 2 except 0 to the real number except open interval minus 1 to 1. In the same way, inverse of the cosec function. Cosec inverse is a mapping from real number except open interval minus 1 to 1 to the closed interval minus pi by 2 to pi by 2 except 0. So then definition of the inverse of cosec function. Inverse of cosec function, cosec inverse x. The function f is mapping from closed interval minus pi by 2 to pi by 2 except 0 to the real number except open interval minus 1 to 1. Defined by the function f of x is equal to cosec x is a bisective function. Then f inverse is mapping from changing the domain and range are real number except open interval minus 1 to 1 to the closed interval minus pi by 2 to pi by 2 except 0 is also bisective. Because the function is bisective, then inverse function is also bisective. This function is called inverse of cosec function and it is denoted by cosec inverse x. From the definition of the inverse function, first note cosec of cosec inverse x is x for all x belongs to the range of the cosec function. And a second note, cosec inverse of cosec x is also x for all x belongs to the range of the cosec inverse function. This is the definition and graphical representation of the cosec inverse function. Definition and graphical representation of the secant function. Here y is equal to secant function. This is the graphical representation of the secant function, and domain of the secant function is all real number except 2n plus 1 pi by 2 values, and the range of the secant function is all real number except minus 1 to 1 value. The secant means 1 by cosec. It is a reciprocal of the cos function. If cosec equal to 0, the function is not defined because 1 by 0 is infinity. So domain of the secant function is all real number except a real number at which cosec is 0. So that is 2n plus 1 pi by 2 values. So therefore domain of the secant function is a real number except 2n plus 1 pi by 2 values. And using the secant values, secant 0 value is secant 0 values. So using the cos angles, cos 0 value is 1, secant 0 values 1 by 1 is 1. So here secant value is secant 0 value is 1, and a sec pi by 2 value is infinity. So because cos pi by 2, cos 90 value is 0, secant pi by 2 means 1 by cos pi by 2, 1 by 0, it is infinity. Secant pi by 2 value is infinity, or sec minus pi by 2 value is also infinity. This is the graphical representation of the secant function. Secant function is also not bisective function over their natural domain and ranges. Restrict the domain values. Now here restrict the domain value from, observe this graph, restrict the domain values from 0 to pi. Restrict the domain values from 0 to pi except pi by 2 values. So observe this graph, 0 to pi including 0 and pi, but except pi by 2 values. So this is the bisective secant function. Closed interval 0 to pi except pi by 2 values. Same way, restrict the domain value in the interval, closed interval minus pi to 0. So observe minus pi to 0 except minus pi by 2 value, or closed interval pi to 2 pi. Here 2 pi, pi to 2 pi except 3 pi by 2 values. Secant function restricted to any of the interval, closed interval 0 to pi except pi by 2, or closed interval minus pi to 0 except minus pi by 2 values, or closed interval pi to 2 pi except 3 pi by 2 values. Y is equal to secant inverse x. This is the graphical representation of the sec inverse function, changing the domain and ranges of the sec function. Here domain of the sec inverse function is all real number except open interval minus 1 to 1 value, and the range of the secant inverse function is all real number except 2n plus 1 pi by 2 value. And we restrict the domain values in secant function. So here secant inverse x, this is the graphical representation of the secant inverse function when we restrict the domain values in secant function. The interval is a 0 to pi value, so including 0 and pi value except pi by 2 value. The branch with a range close interval 0 to pi except pi by 2 value is called the principal value branch of the secant inverse. This is the principal value branch. So therefore domain value of the secant inverse function is all real number except minus open interval minus 1 to 1 value. A range of the secant inverse function is a closed interval 0 to pi except pi by 2 values. So consider y equal to secant x, y is equal to secant inverse x. When we restrict the domain function or secant, when secant x or sec x is a bisective, domain of the sec x is a closed interval 0 to pi except pi by 2 values, and a range of the sec function is a all real number except open interval minus 1 to 1 value. And secant inverse function, domain of the secant inverse function all real number except open interval minus 1 to 1 value, and a range of the sec inverse function is a closed interval 0 to pi except pi by 2 values. And definition of the inverse of the secant function. Inverse of sec function, sec inverse x, the function f is mapping from closed interval 0 to pi except pi by 2 value to the all real number except open interval minus 1 to 1. Defined by f of x equal to sec x is a bisective function, then f inverse is mapping from all real number except open interval minus 1 to 1 value to the closed interval 0 to pi except pi by 2 value is also a bisective function. This function is called inverse of secant function and it is denoted as a sec inverse x. By definition of the inverse function, secant of secant inverse x is a x, or sec of sec inverse x is x for all x belongs to the range of the sec function. And a second note, sec inverse of sec x is also x for all x belongs to the range of the sec inverse function. This is the definition and graphical representation of the sec inverse function. Okay, now we will discuss about the inverse of cot function. See here y is equal to cot x. Domain of the cot function is a all real number except n pi value, and the range of the cot function is a all real number. Domain value is a all real number except n pi. It means cot x means it is a reciprocal of the tan function. So if tan x equal to 0, the cot function is not defined. Therefore, the domain of the cot function is a all real number except real number at which tan x is 0, that is n pi or minus n pi. So minus means except the n pi value. So range of the cot function is a all real number. This is the graphical representation of the cot function. And like other trigonometric function, cot function is also not bisective function over their natural domain in ranges. We make it invertible by restricting the domain value. So here we restrict the domain value to the interval 0 to pi. So but exclude 0 and pi value because in these values the cot function is not defined. So that's why the cot function is restricted to the interval open interval 0 to pi, or in the interval restricted to the interval minus pi to 0 also open interval minus pi to 0 also the chord function is a invertible. In the same way pi to 2 pi. And in restricted chord function, domain of the chord function is a open interval 0 to pi and the range value is a all real number. In inverse of the chord inverse function, so here restricted chord inverse function 0 to pi. So we restrict the domain of the chord function is the open interval 0 to pi. So here inverse means changing the domain and range. So here domain value is all real number, range value is a open interval 0 to pi. And definition of the chord inverse function is inverse of chord function, chord inverse x. The function f is mapping from open interval 0 to pi to the all real number defined by f of x is equal to chord x is a bisective function. In this domain and range value, chord function is a bisective function. Then f inverse is mapping from all real number to open interval 0 to pi is also bisective function. This function is called inverse of chord function and is denoted as a chord inverse x. X means angle. And from definition of the inverse function, chord of chord inverse x is a x and chord inverse of chord x is also x. So these are the graphical representation of the inverse of trigonometric functions. In next class we will discuss about the principal value and some examples based on the principal value. Thank you.